So, okay. Sometimes in the machine shop, we get parts that we just have to make, and we have no idea what they're even for, where they go, or anything like that. So, what I'm going to tell you is you were emailed this drawing. This is not a, how do I say it? A drawing that would be submitted. This is not, I don't know the right word. This is not a professional drawing, okay? I've done this drawing to keep things very simple and simply for communication, which actually is what I think drawings are all about. As long as you can make the part from the drawing, as far as I'm concerned, there's no such thing as a bad drawing, all right? So, I'm not going to tell you what these parts are for, this small assembly here, but you will see at the end. And so this is the first one, and let's take a look at this. You can see here we've got this round material, some square material, a knurled, which we'll do, a knurled nut, and then this brass. It's a clamp, basically. This whole thing is, when you screw the knurl, it's going to clamp. The only part we're not going to make is this 1032 screw here. It's stainless steel. This is called a button head screw, okay? A button head cap screw, excuse me. And yes, my hands are dirty. I've been cleaning. I felt bad for you guys because it was so messy, and plus it was too dirty for me too. So I think we're going to get started here on this, and on the simplest part, which would be this bar right here. So this is the isometric view. In case you don't know what that is, that's a projected view. It's called an isometric. Kind of gives you it's like a perspective. I wouldn't say it's 3D, but it's a perspective drawing. And down here, what we have is the front. And then over here, this would be the right, okay, the right view. So we can see here that this piece of stainless steel rod is 2.375, so that's 2 3/8, and it's 5/16 in diameter. And then I made it a note over here, and what we're going to do is we're going to ease off these edges. Instead of actually machining in this radius right here, I'm going to use a file and some sandpaper. So if we go over here, you can see here's our material. Here's the 5/16 that we'll use right now. Here's the block that we're going to take down to 3/8 roughly with that angle. Here's the nut, the 1/2 inch knurled nut that we will machine. Here's the screw. Here's the brass. Actually, I think this is bearing bronze. It's not cheap, but that's what we're going to use. And okay, so we're going to do. I'm not even going to use the bandsaw. I'm just going to. I'm going to use the hacksaw to cut this material. I think it'll work, even though it is stainless steel. It's pretty tough, and. So right now I'm doing this one-handed, so let's see here. I'm just going to, it's 2 3/8, right? So we need to leave ourselves some space. And so I'm going to put the scale, this is not a ruler, it's a scale, at about 2.5, all right? So that's an 1/8. And then I'm going to make a line here with my Sharpie, believe it or not. And I'm still, when I cut it, I'm going to leave the line like we've talked about, and that'll make it even larger than, a bit larger than 2.5, okay? And then we'll machine, and we'll face down the edges, and then we'll ease it and polish it up, okay? Yeah, it's a little shiny over here. I wanted to make sure that this would buff out okay. So we're going to go over and cut this. These bronze vice guards, they're actually called soft jaws. And what they do is they protect the jaws from the vise from marring the rest of the material. It could slip around on me a little bit. Hopefully it doesn't. Let's see here. Yeah, there we go. Okay, and got my hacksaw, right? And very lightly, I'm just going to score it about a 32nd away from that line. Okay, I just boom right there. Okay, hit it. It's stainless, so I'm gonna hit it again. And then, as we've talked about, I am going to. It cuts on the push stroke, so I'm going to cut on the push, and then I'm gonna let go almost, and just guide it back through and lift up slightly. Okay, using the whole length of the blade as much as possible. Oh, shoot. Yep, that happens. All right. It is stainless, so it's kind of tough stuff. All right. Now what I'm going to do is I'm going to go over to the disc sander, and I'm going to clean up these edges. All right. And I'll explain why I clean up the edges soon. Takes. Doesn't take much. It got a little warm. Okay. That should be good. Turn off the sander. And now we're going to go to the lathe, but we're going to make a pit stop. And what I have out for you to see here are, I've got 4 chucks out on the bench here, and then there's one behind me mounted in a lathe. So what we're going to talk about just real quick are different ways to hold material in the lathe. And we're going to look at 4 chucks, okay? Actually 5. So this is the 3-jaw chuck. Remember, I have what they call soft jaws in here, and these are my aluminum jaws that I can machine. So after I machine them, they enable me to take parts in and out. And they're not exact, but I can get them in. You know, I get the parts back in within 1/1000th of an inch, or 1/1000. Let's just say 1/1000. You know, and then it's soft, so they do need to be machined to hold that tolerance. They're not the best. Okay, we'll go to the best next, but for what I do, especially in the time frame that I do it in. They really are nice to have. I make them and they just bolt on to the jaw. Maybe sometime, if we have time, you'll see me work on these a little bit. Okay. I would say this chuck is the most accurate, and it's very easy to use. It takes some practice, but this is a 4-jaw chuck, and you can hold rectangles, squares, anything that'll fit with 4 parallel and perpendicular surfaces. However, you can center something round in here perfectly, and that is ideally what they are great for. Each jaw moves in and out independently, as opposed to the 3-jaw chuck, which is, as you already know, on a scroll. Okay. I do like the 4-jaw chuck the most, although I don't use it the most. I use the 3-jaw with the soft jaws, like for reasons I already explained, but this is the way to go, okay? The next chuck we'll move on to, this is called a 5C collet holder, all right? And we're actually going to use this right now. So I'll stop talking about this because we're going to see it in action, okay? This is what's called a faceplate. And so this can go on the spindle of the lathe as well. And what's so cool about this is that I can put whatever shape material I want on here. And I can move it around and index it to center wherever I need to, okay? This is advanced machining, so we're not going to probably do this semester. Plus the projects that I've designed, like I was telling you, the surprises, I don't think are going to call for this. But I want you to know that this is here too, all right? And so there's one last chuck I want to show you before we get started on the lathe, and that's right over here. Get my phone. This is a 6-jaw chuck, and it operates on a scroll as well. You know, just like the 3-jaw chuck. So often you might wonder, well, why do you need a 6-jaw when you've got a 3-jaw? Well, there's many uses for a 6-jaw chuck, but primarily the biggest reason for a 6-jaw chuck is that if I had a really thin wall tubing in here and I wanted to machine it, the pressures from the machining operation will deform the very thin walled tubing, and the 6 jaws gives that thin wall a lot of support. All right, so that's the reason for that. One of the many reasons. That's maybe the biggest reason, although I could be wrong about that. But I just wanted to point out there's other chucks too, by the way. Okay, there's lots of different styles of chucks to put on the spindle of the lathe, but these 5 are definitely the most popular, and probably the best one is, it's hard for me, I'm not coming up with a better term than best, but this is, the 4-jaw is the one you want to use, all right? Although here at the school, the chucks that we have are usually, the lathes set up in the makerspace are 3-jaw. Okay, so we're going to go ahead and we're going to put this 5C collet holder in the lathe. Let's go over there. So here we are. Let me get this set up here. All right. I think that's pretty good. I got it on the carriage so I can move the fancy pants. All right. Here is the taper on the spindle, okay? And then, or you can't see, well, yeah, you can. I can move the camera. There's a key there too. See that key? Okay. And then this is what this threaded ring is what screws it on. It's reverse thread, so it's left-hand threads. Now, it just so happens that the 5C collet holder or chuck is pretty lightweight. It's not 30 pounds, so I can go ahead and grab that without needing some help. And here it is. So I'm going to put this here, and okay. Before I get started, remember when we were moving the vise around, and I was stressing that you can't have any chips in the under the vise and on the table. Well, it's the same here. You really do not want any chips on this taper or in the chuck. Okay. So I already cleaned it actually, but I just wanted to point that out. And then now what I'm going to do is grab this. It's still not light, but it's not as bad as, all right. And then I'm going to thread this on that tapered spindle. Okay, got it. And then this is called a spanner wrench. Okay, And it comes around here like this, and then you tighten it on. Here's my dead blow hammer, and okay, there we are. So I got my, of course, I have my glasses on, and what I'm going to do is I'm just going to turn the lathe on real quick, make sure that I got that on right. That looks pretty good. All right. So if you remember, our material is 5/16. So grab that. 16ths. This is a 5/16 5C collet. So up here, I think you'll be able to see that. You can see it says 5C. That's the brand. Hardinge. They're nice. They're also very old, and it says 5/16. And so what happens here? It's a collet, and there's a keyway right here, and that just keeps it from spinning. That doesn't drive it. What drives it is the taper, and we've talked about that, but that's really important to just kind of know. And so inside there is a little key. You can feel it, and then you just slip this in. There, see, it went in with the key, and this spins like that, and it as it draws it in, it tightens on the collet. So I'm just going to put this in here. I got about, I don't know, a ½ inch sticking out, and I just tighten it up hand tight like that. Okay. All right. So let's see. And I'm going to go ahead and I'm just going to use stainless steel. All right. And I'm just going to go ahead and I'm going to use my a regular high-speed steel tool that I ground, and I just used here. So I'm hoping you'll be able to see this. There's that pin I was telling you about, and there's now on the other side is the set screw. So I'm going to drop this here on that dovetail, okay? And with this hex wrench or Allen wrench, I'm just going to get this close here to the center, okay? And I adjusted all these. I messed them all up because let me explain a little bit more about this. This is really cool. So these are what they call KDK quick change tool post and tool holder. I had mentioned that, but once these set screws are adjusted, you can take these in and out, right, and not have to adjust the height again, and that's why they're called the KDK quick change system. So I put that in there. And now this just gets you close. This isn't perfect, all right. So I'm raising the tool up by tightening the set screw, and then when you pull on the dovetail there, it kind of pops it up, right? So when it's not locked, you don't want to get it perfect. You want it to be a little bit low, okay? And then you just eyeball it. You get in there, and so just a hair low. So I'm just gonna that's it. That was about 1/3 of a turn. So we'll start there. That's pretty close, okay? I'll get the tailstock out of the way. And what I'm going to do is I'm going to face this part here. I think you can see that pretty good. And so I'll on the next shot, I'll put the camera on my head, you know, like I do sometimes. So I'm tightening this up, tightening the tool post nut. No, you can't see that, or screw. And I'm just going to do a touch off, all right? And I'm going to face this smooth, making sure that I don't take off I got to do the other side too, so I don't want to take off too much, all right? It's stainless steel, but it is small. So I'm gonna set the lathe to, let's just start at 350. See what that looks like. I think that might be a little bit slow. All right, I'm gonna go to 494. I kind of like that better. All right, and then I'm gonna check my power feeds here. So my power feed speed looks good, but I was going the wrong way. Okay, so I'm gonna do a touch off. And see how this. So it's stainless steel, so I'm going really, really slow. Oh, see that? Okay, so remember how I told you that it's just a rough, okay? It's just a rough height. There's a little protrusion or a nipple coming out of there. I need to raise the tool up a bit, okay? And right about there. I want you all to know too, I wanted to say this at the beginning, that I haven't made these parts and yet, so I'm hoping things go wrong. They're pretty simple, so I don't know if they will, but I'm hoping something goes wrong. So I need to raise the tool up a little bit more, just a little bit, there. Okay, and I think that's good. A little bit, just a hair more, there we go. So stainless is really great actually to work with. The reason it's so great to work with is that it holds everything that you want to do. So what I mean is that it kind of holds its tolerances really, really well. And I'm just going to run this in by hand. I'm not even going to use the power feed. I'm going to go really slow. Are always a little bit tricky sometimes. Let me see what I can do about this. All right. Okay. Now what I'm going to do is I'm going to take my file, you know that small, it's a, I wouldn't say it's a needle file, but it's a toolmaker's file, and I ground my triangle file, I ground one corner, and I'm just going to start easing this edge here. Make it so you can trying to move my arms around so you can see it. And I'm going to make it round. Because I am going to use some sandpaper to remove those file marks. I'm going to start with 400, and here's tip of the day. This piece of rubber right here is from a bicycle inner tube. So when I get a flat, I take my bicycle inner tube and I cut them up into these squares or rectangles, and I use this as a sanding pad. They're the best sanding pads. So I'm going to see if I can get this so you can see here. I'm going to take the tool out. Let me turn. You got to turn the lathe off. Take the tool out, by the way. So I'm going to take the tool out. Maybe that'll help me get in there closer, and so you can see. hit this a little bit more off camera just because this is very boring to watch. Okay, so that's some 500, and now what I'm going to do is I'm going to move into some 800 here. Starting to look good. Okay, so there's one side. All right, there we go. Okay, so far, that looks pretty nice. Okay, so see here what we've got. Well, we've got a ways to go on this one. So this is saying 2 inches and 555 thousandths roughly. Okay, let me just knock off about 100 thousandths, and I'm going to take it back out, and then I'm going to show you the strategy here on how we're going to get this. Okay. I slowed down the speed. It seems to be, I put it at the 350, and it's cutting a lot better than it did. I think I'm a little bit high, just a little bit high. Yeah, nailed it. Okay, we are on. So let me hit this quick here one more time. All right. Okay. Now what I'm going to do is I have this device here that I made, and it's a piece of aluminum block, and this slot here and this nut or screw, backwards today, locks it onto the ways of the lathe. So that goes here. And then, oh, geez, it has a dial indicator, which is a 2-inch throw on it, attached to that block. So I can move this around on the ways of the lathe. And what I'm going to do is I'm just going to, the dial indicator is going to hit the side here of the carriage. And I'm just going to preload it a little bit and tighten this screw, okay? And then the face of this turns. So I can make that say 0. Okay, so watch this. And when I move the carriage back and forth, you see that? It's moving, and I'm able to control how much I'm cutting on my depth, all right? So I'm just going to arbitrarily cut 9 thousandths, right? I'm going to say, okay. And guess what? If I don't move the handle or the carriage back and forth, and I put this on 0, I've just zeroed out the machine, all right? Now I can move it around all I want, and I've always got my 0, which is exactly what I'm going to do, all right? So what I'm going to do, and yeah, I know, is now I'm going to take this out, but we're going to do it again because you'll see what's going on, all right? Yes, I lost my 0, but that's not the point. The point was to understand the device. So if we see here, I've got, all right, I've got 2 inches, obviously. So I'm just going to stop saying 2 inches. About 484 thousandths, all right? We don't need to be totally spot on. I want to be close, but we don't need to be. I'm going to let this come out just a little bit more. Give myself some space, which is the space is everything for the filing and the sanding. All right, so there. What I'm going to do is really lightly just touch this, and then I'm going to preload my indicator again. Put it on 0, all right? And if I were to do this, I'm going to be a thou or two off, okay, for sure. The other way that I just showed you, I would be spot on. I have to remember what I said, 284 thousandths. Okay, so 284. We need to go to 375. All right, so 84, okay, takes us to 0.4. Remember, I'm not going to say the 2 anymore. And then another 25 thousandths. All right, so we can add that up, or what we can do, let me just show you. This is the way I like to do it. I'm going to go ahead and take the 284, and I'm going to do exactly what I just did again. So there's about 20 thousandths. Nice and slow. Stainless steel, so we got to go slow, especially on these little parts. There's another 20. Okay. Another 20. I want to leave myself some meat, so I'm going to go to 75, so that's 15. And now I'll just take it to 84 on the dial there. And I have two choices. At this point, I can take it out and I can see if that I'm at 2.4 exactly, or if I don't want to do the math, I can just make this say 0 and I can take my 25 and that will go to 2.375, which I think at this point I'm going to do. So I'm going to go 15. You see that? There's 25, and this is my finish pass, so I'm going to go really slow. All right. That looks pretty good, okay? I'm going to pull the tool away now because on the carriage, so I don't have the camera on the carriage anymore. I'll get it out of the way. And I'm going to start doing that rollover technique. I'm going to really get in here for you so you can see what I'm doing. Turn the lathe off. Pull this out. There's our part. We gotta. I'll come back off camera and sand that, so it will be. You won't be able to see it. So I said 375. We are at 373. So I'm 2 thousandths under, but I'm totally okay with that. Yeah. For what we're doing, oh, actually, I'm a 1.5 thousandths under, okay? So that's 273.5, 274. I'm 2 thousandths under. Fine. So there's this part, okay, or this part. We still need to drill a hole in it, but we're gonna, when we set up the mill to drill a hole in the square one too, we'll do it then. The next thing we're gonna do, I think, is we are going to do the knurling, okay? What I'm gonna do is I'm going to take out this collet, and I'll show you my collet rack. All right, so 5/16. Now we want a half, which is right here. Go ahead and put this in. And what I'm going to do is I am going to send this material all the way down. Oh, hang on. Let me get this going first. Alright, so this is going in, and I'm going to send this all the way down the pipe. And so the general rule I'm going to break, because we are going to be using this. This is called a knurling tool. I'm going to use the coarse wheels, okay? This particular knurling tool is a KDK quick change knurling tool. There are two wheels here that will ride on the material, and don't worry, I'm gonna keep going. I'm gonna explain this and explain this and explain this. Okay, so we've got coarse, we've got fine, and we've got medium. Okay. I'm going to use the coarse. I like the coarse one, especially on the stainless. It's going to look really nice. Knurling is a forming process. It is not a cutting process. This part here, it's got threads in it. It's got 1032 threads in it. You can draw that. All right, so it's got number 1032 threads. All right, I'm going to do them on the lathe. You'll see that. But the order of operations here is kind of interesting, because what we've got is, if we look at the side view of this part, we got the knurling here. Okay, we've got chamfers on both sides and then threads, right? Okay, that's like the Soda Wave. So what I'm going to do first is I'm going to face it, then I'm going to thread it. So I'm going to face it, thread it, then I'm going to knurl, then I'm going to I'm gonna groove it, but just partially down to about here. Then I'm going to chamfer it, and then I'm going to part it off. All right. The reason why I'm going to groove it in between is because I want to get that chamfer in there. I want to do it all on one. I don't want to have to flip the part around or anything. So that's, I hope that makes more sense now. I know I wasn't very clear before. I'll get better at it. Okay, let's go. It's a chess game. All right, so make sure when you walk away, you want to make sure that, right, I don't want this thing to be flying out. All right, so what I'm going to do, I'm going to go ahead and face this and move my indicator out of the way. Drop my speed back to 350. That seemed to be working. So I'm going to touch off, right? I'm just going to go ahead, and it already has a hole in it. So I'm going to I'm going to face out that hole. Trust me, it's faster than cutting it off. And come around here That looks fine. All right. So what I'm going to do, go ahead and take this out. My live center. Yes, I cleaned up. Finally. All right. Here's my drill truck. Okay. All right. And motor oil. That's what I like. It's cheap. It works. Let's see. Yeah, that'll be fine. I'll put my face in there, even though I don't want you ever to do this. All right? I don't want you. I'm doing this so you can see. All right? You see that? I'm about a millimeter away from the. See that? Okay. Please don't ever do that. So I'm going to loosen up the tailstock, bring this back, and I'm going to take out my center drill. Okay. 1032. So here we are. 1032 threads, drill size number 21. So I've got my 21 size drill. And I've got my 1032 tap. Remember, don't need to go around. Don't need to go all the way around. Whoop, got close there. So I'm gonna lock the tailstock, and I got this up close. Just gonna pop a little oil on there. With aluminum, I use WD-40, but with the stainless, it's good to use some oil. I could use WD-40, but oil's better. So this is a through hole, right? So what I want to do here is let me turn this off. What I'm gonna do is I'm going to put if you can see, there's a scale on the ram. I'm going to make that, I just locked the ram. I'm going to use the ram because I'm a through hole, and so I definitely want to go all the way through, and I'm going, through the part, I mean, and I want to be able to part it off with a hole in the middle. I don't want there to be solid material, and I'm going to use this spiral tip tap. And you can see that the threads, right, are only full threads, like starting there, which is probably, looks like over 1/4 inch, okay? So we've got the width of the part, which is 0.2 inches, and I will just say, okay, that's 1/4 inch. Plus I got to do another 3/8 inch to make sure I've got full threads and enough to part off, okay? So 1/4 and 3/8, that's 5/8. So I'm going to drill about 5/8 inch into my part. And what I'm going to do is I'm going to look here at where the drill starts to become after the cutting point. I'm going to line that up. I'm going to put this at 1.5 inches. And then I'm going to tap this right there. Lock the tailstock, unlock the ram, and I can just watch the scale on the ram, and I'm going to go roughly 5/8. So I'm going to just drop a little. I mean, that's even too much oil right there. You don't even. Okay. So there's 3/8. And I'm going to peck. So I'm going to bring it out These are small, guys, so you gotta be really gentle. All right, so let's see. That's a half. Bring this out again. Okay, there's 5/8. I'm gonna go a little bit more. You don't need to, but I'm gonna do something here. Okay, so we're gonna back this out of the way, and there. Okay, take my drill out. Tap in. And now what's going to happen is every machinist in the world is going to freak out when I do this and be like, oh my god. I'm actually having second thoughts about doing it this way. I think I'll do it this way. I'm just going to get this started here. What I'm doing is I'm actually turning the chuck and the ram at the same time. So I'm pulling this way and I'm turning the ram that way. I know everyone's gonna freak out, but I got it going straight just now. Okay, so I'm just gonna loosen the chuck, get this out of the way, move the carriage out of the way now, and use a tap handle to finish this off. Okay, and when you're tapping by hand like this, what you need to do is you do about a half a turn, and then you do a half a turn backwards, and what that does is it breaks the chip. So remember, the chips are going this way, so I have to feel it getting, if it starts to get tight in there, the tap will break. It'll just go pop. So I'm going about a half a turn and then going in reverse, and I'm just going to keep going until starting to get chippy. There, that's it right there. I could go a little bit further, but I think there's too many chips in there, and I don't want to run the risk of breaking the tap. Okay, and that's super. Really don't want to do that. So I'm going to back this out. And now rest by hand. Okay. So there's some. You just tap that. I'm going to, this is for the secret project, I'm just going to machine off a little bit of that countersink, because I know what this is, and slow, really slow. You guys, this is all for looks right now. This is not for, yeah, that's it. Yeah, that's it. That was all for looks, okay? All for looks. So, let me move this sandpaper out of the way. Okay. All right. So next is knurling. It's got a burr on there. So what I'm going to do is I'm going to file that burr off. I'm going to use this as a regular file because I don't need, you know, I'm going to chamfer it there anyway. But what I want to point out, and I didn't on the small file on purpose, is that most people are right-handed, and they're going to have a tendency to want to do this, okay, with the file on the lathe. You really can't do that. That's you're just asking for it. Your left arm's right here. If you had a sweatshirt on or a long sleeve, I know this is round, but the regular chuck, I mean, you've got to get into the habit of filing on the lathe left-handed. Okay, so I'm going to hold the file with the handle in my left hand, and I'm going to support it with my right. Okay. And all I want to do is get rid of that burr that's there. I'm not going to chamfer it. Just wanted to get rid of that burr that was there for knurling. Okay. All right. Let's see. So here we're going to knurl. I'm going to give myself a little bit more space. Space is the setup and space. I mean, that's it. That's the ticket right there. Really is. Okay. So, all right. I've seen a lot of people knurl like this, and I don't do that. I actually knurl pretty textbook. I knurl straight, okay, and like I said, knurling is not a cutting process, it's a forming process. So what it's actually going to do is it's going to make my material, it's forming it, so it's actually going to make it a little bit bigger. And we're going to put nice diamonds in here. All right. And I really should, especially for class, you know, get the square out, and I got to move that, get the square out and all that. But I also want to show you a different way of seeing. And I've mentioned that a few times. And so what I'm doing right now, right, this is loose, is I'm looking at the top. I'm looking at the top of the knurl right here, okay? Let me put my face in here. I'm looking at the top of the knurl, and I'm also looking at the bottom or the top of that, all right? And I'm kind of moving my head around, and I'm looking at the bottom here and the top, and I'm looking for any kind of gap, and I'm making sure that that's pretty straight. Now what I'm doing actually is I'm looking at the light. So the light has these beams, right? These beams on it, and I'm making my tool parallel with the light beams. All right, so that's parallel. I know I just tightened that up. This is a forming process, so you do need to be a little bit snugger on the tool post. Okay, really the only time. And then what you want to do is come around here and make it relatively. So I'm a little bit high, so I'm just going to adjust that, and I'm just eyeballing it. Yeah, I could bring the center over and put it on this pivot point, but I don't think that's necessary. Not for knurling. I'm going to just drop this down just a little bit here. Just eyeballing it. Yeah, that looks pretty good. That's pretty dead close anyway. All right. And I'm going to set the machine up. I'm going to cut air because I'm going to use the power feed. Once you make contact and start knurling, you are fully committed, okay? There's no way, if I back this off the let me show you. If I back this off the material like this, okay, and then I can never find my spot again, all right? Like threading, I know we haven't done that yet, but there's no way for me to chase my spot, all right? So once I start, I'm committed. So what I'm gonna do is I'm gonna lower my speed, maybe even lower, because it's stainless. So I'm gonna go to 130, and then I'm gonna engage the power feed. Okay, first of all, I'm going the wrong way, so I'm gonna flip the lever. Remember, the lever makes the power feed go the other direction. And I'm actually gonna go to coarse and see how fast. Yeah, I like that. So what I'm doing is I'm looking to see how fast it's going. And that's too fast. I'll go back to fine. All right. I'll take it. All right. And, all right. So I'm going to engage here, okay? And remember, I only have to knurl a little bit, right? Just a little bit. So I'm going to engage my knurl, and I'm also going to give it a little bit of oil here. More than I would if I was cutting, but not too much, all right? And now I'm going to apply some pressure. I'm going to apply pressure on the cross slide. I'll go ahead and engage my power feed. It's going pretty slow, so I'm just being pretty patient. Okay. Disengage the power feed. Turn off the lathe, and you can see the diamond starting to form. You see that? All right. Are you happy with that? You got it. You say to yourself, nah, I want to go more. Do not disengage the tool, okay? So what I'm going to do is I'm actually going to put the power feed to go this way. I actually could put the spindle in reverse, but this is the way I do it. I'm going to put a little bit more oil on there. So I'm going to give it more pressure. Engage the power feed. It's just going slow. That's okay. That's okay, see that? It's just going really slow. That's okay. And then, of course, I don't want to fall off the wheel because then I'll lose my spot. Okay, so right about there, I can stop the power feed. And I can look at my knurl now. And I'll say, you know what, I want to go a little bit more. So I'm going to put that into not forward, but this direction. And turn it back on. I'm going to give it a little bit more pressure. Turn the power feed on. So I'm forming that diamond. Okay. Turn this off. All right, now we're getting somewhere. So let's see what this looks like. Actually, I'm about there. Yeah, that's it. We're done. And I'll pull the tool off now, and you'll see what that really looks like. Okay, take the tool out. All right, so there it is. That's knurling, okay? And nice pattern there. And what I'm gonna do now is I'm gonna put a groove in here, okay? The part finished is 0.2 inches in thickness. So check this out. All right, so I'm gonna need my depth gauge again, The parting tool itself is 1/8 of an inch. Okay? So, watch this. First thing I'm going to do is I'm going to make this parting tool straight. Pretty straight, at least. Alright. I'm just eyeballing it, guys. Alright. And the other thing I want to do is, we'll talk about this again, but I want to run my parting tool just a hair positive. What do I mean by a hair positive? I mean just a hair positive. I'm going to put the center back in so I can explain it. I want my parting tool to be positive, meaning up above center, just a little tiny bit. Okay, and so I'm going to take a look at that, and I am. Okay, and I'm perpendicular, and so what I'm going to do is I'm going to rest my parting tool on here, right, on the edge. I'm going to zero out my indicator. Rid of that chip. All right, and I'm going to, now I got it all zeroed out. I'm going to bring this around, and I'm going to, there's 0. Okay, that's where it was. Remember, my parting tool is 1/8 of an inch. Okay, so I'm going to move this over 0.125. All right, and now this edge is zeroed out to the edge of my part. So now, however thick I want my part to be, which happens to be 0.2, I can zero out my depth gauge here, my indicator, and I can go 100, 200. Okay, and now we know that we're right there. Okay, and yeah, it looks good. This project I designed in SolidWorks, so I'm looking at stuff and I'm saying to myself, you know, I kind of want it just to be a little bit bigger. Okay, I know that's not okay. We'll go 0.225. I know that's not okay. I know that's not, I know, but real life here. All right, now speeds. We're gonna want to go slow. So I'm gonna put this 179. Yeah, looks good. And definitely some oil. I'm not going all the way because remember I want to chamfer. I'm just going to chamfer next. That's not much force, so just don't want to. All right. I could probably touch up my parting tool. All right. And get this out of the way. I won't touch my indicators, and I can always go back. Well, that's actually not so true. Okay, I'm gonna eyeball everything from now on here on this part. I'm gonna put a chamfer on here. Actually, I'm gonna stop. Okay, why did I just stop? The reason that I just stopped with my chamfering is because I want the chamfers to match. All right, so check out what I'm going to do here. I know it's not the same. I know it's not the same as being in the lab. I know. We're doing it though. We're doing it. All right. That's pretty good. I just checked the height, by the way. And I'm looking to see, that's pretty good. So let's run a little chamfer there. I like that. Let's see what that looks like. Yeah. I'm gonna hit it just a little bit more. Yeah. Yeah. All right. Yeah. Now switch tools. Put the parting tool back in. And what I'm gonna do is get the parting tool lined back up. Yeah. Looks good. I'm going to put a little oil in here. And let's see. There it is. Ready? I'm going to use the Allen key T-handle to catch my part. Actually, it's too big. Part so tiny. I'll use the file yeah. So here's my, it's still a little warm. I'll thread it with the screw. All right. So this remainder from the parting tool, I will get with the grinder or the sander. Okay, I'll show you that in a minute. Let's let the part cool down a little bit. Okay. And there it is. It actually looks pretty good. So that's almost 2 parts out of the way. Let's move on to the last thing on the lathe, which is this 3/8. It's the 7/8. So it's 0.85 actually in diameter. It's 3/16 or 0.875, 1.188 in thickness, and it has a 1032 tap in it. All right. So here we go. Let's do another one. Drop this in here. First thing we're going to do is face. Same tool that I've been using. Cut with the tip. All right. Tool. Yeah, it's fine. Cut with the tip. I'm changing my speed though, brass. So I'm gonna go up here to about 650, and all right, that looks pretty good. And that looks good. Let's see here. Oh, go the other way. see. So that's not a very good finish. All right. I could touch up my tool, but I think what I'm gonna do, for the sake of time, carbide finishing tool, and see how. So that looks a little bit high. All right. Let's give that a try. And let's see if this makes a little better finish. Yeah, I can already tell. Yeah, that's nice. All right, I'm just gonna bump that tool up just a hair. And right about there, I think. And yeah, looks good. One more time, let's see if that, yeah. So touch off, barely. Don't even need to cut very much. Good. Get this out of the way. And I'm just gonna, I'll use this. I'm just gonna break that edge. Remember, left-handed. All right. Now I'm going to make some threads. Same as last time. Get this out of the way here. This 1032s again, but let's put a center in. Always put a center in. And all right, lock the handle. Oh, good. So much different than the stainless. All right, that's pretty good. Take this out of the way. Okay. Right there. Okay, this time, that looks great. All right, so what I'm going to do here, this up, same thing, only this time, I'm only going to go like 3/8 of an inch deep. So I'm watching the scale. There's an 1/8, there's a 1/4, and there's 3/8. And if I don't get threads all the way through, I can always do that later. Not a problem. But I want to do threads on the lathe, so that way I know that they go straight. And so I'll just extend this ram a little bit before. All right. Okay, I'm gonna lock this, and yeah. Okay. I'm gonna pop a little WD-40 in there and get this started. And I'll do the same thing I did last time. Come on, Blake. All right, there we go. All right. There we go. And I'm feeling it. I'm letting the tool do all the work. It's a nice sharp tap. And there, I just hit the bottom. Back it out. All right. Okay, so let's turn this down now to about 850 and adjust my tool. So I'm cutting with the tip. This, like I said, this is a finishing tool, so I need to take light passes. By the way, I'm starting at about a little over an inch. So I'm just going to touch off here. And what I'm going to do is, I don't know, I'll take 20 thousandths there, and then I'll zero this out. So you can see, I usually don't do that. I just do the math, but it's a little bit easier. And I'll use the power feed, but it's going the wrong direction, so I'll lathe off and so we're going to go about 200 plus. I'm going to part this off so you can just get a visual here. So I need to go a little bit more, and I'm going to go, let's do 250, okay? We can eyeball it, or we can use I'll use the gauge. So I just barely touch that, and it's not, this isn't important because we're going to be parting it off. So I'll touch off again and say 25 thousandths, and what I'll do is I'll watch the indicator, and so 100, 200, and then 50 is where I'll stop. So there's 100, 200. That's a heavier cut. It's not liking that. It's saying, yo, not good. 250. Okay. And you can see that it definitely did not like that at all. It's okay. So let me just do another 25. It didn't like that because of the finishing tool. So what I'm doing now is I'm watching the lines, and then I'll finish off on the dial. Okay, right there. And so my dial says 50, and I'm gonna take a measurement here. Let's see what this looks like. So it says 955. Okay, we want to go to 850. So let's do 250, 225, let's do 20s. And we'll do, there's a 20. $10, $15, $20. Okay, and then I'm going to do 15. That'll pick us back up to a nice round number. am fully aware that some of you might be like, what is going on? But I think the best way is for us to just keep doing this, and you'll see. So I'm at right at 900 right there. Okay, maybe a thou less. I'm at 900. All right. When I take a measurement, what you don't want to do, let me clean this up and then I'll show you. So I'm going to take my 3-corner file because it got heavy there, right? And I'm just going to, and then my corner that I ground off is, I'll make sure is, okay? Left-handed, you notice. And I'm just going to kind of hit that lightly. Now it looks a little cleaner. Okay. Remember what I was saying. Okay. 900. We want to go to 850. So let's do 2 20s on the dial. And 2 20s, and then we'll finish with a 10,000ths cut. Oh yeah, I'm fully aware that some of you are like, what? He just went somewhere, and I did. But I'm not worried about it, because if you're watching the videos, you're eventually going to understand. So there's 20 right there. Do another 20. So now it's a total of 40. Remember, we have to do a total of 50. So there's a total of 40. Now here's my finish for the 10. All right, and this time though, what I'm going to do is, instead of going back, I'm just going to bring the tool out like this, put it off to the side, grab my file, and I'm going to break this edge. Okay. Now, I'm going to part this off, and we wanted it to be 3/16. So let's loosen this up. We're going to use the dial again, and so what I'm going to do is bring the parting tool up to the face here really gently, and with the combination of using my hand and the handle, I'm going to make it perpendicular. So I'm looking at gaps in there, okay? So we'll just snug this up. While it's there, I'll come around here and put this on 0. Okay, so there's 0. And bring this around off the part. There, I'm at 0. So remember, the parting tool is 1/8. So there's 125 on the dial. We'll zero this out, and then we want the width of this to be 0.188. I'm actually going to sand the other face. I'm going to actually sand both faces because I want to polish it, and I'll probably lose a few thousandths. So what I'm going to do is this isn't that important, so I'm just going to do 190, okay? If you're wondering why, so there's 100, there's 190, because I am gonna sand. All right, that'll work. And I'm gonna bring the speed down to 351. Grab my something to, there it is. I'm gonna use the handle so I can grab the part to catch it. Okay. So looks pretty good here, and we're just gonna go slow. Okay. Brass can be a little sticky, so you got to be careful. we got a long ways to go here. No, I don't need any. I could use some WD-40. Sure, why not? Actually, you know what I'm gonna do? So there's that corner that I ground. I'm gonna bring this in here, and I'm gonna chamfer that edge a little bit before it comes off. There we go. So that's gonna be pretty hot. And I'll just, clip that off. Okay. That part's done. So what we're doing is this rectangle, okay? And I did the same thing. So I took up this is a 1/2 inch square piece of stainless steel. I cut it off with a hacksaw, and I just touched it up on the disc sander. I didn't do the face because we're gonna face it on the mill. You'll see what I'm gonna do. What we got to do is bring this part down to 3/8 or 375 thousandths square. And I actually have a 3, but I wanted to show you how to machine it. You'll notice that it says 369 thousandths here, and that's because there's a radius right in that corner. At the high end, you can see that angle. We're gonna machine that angle in. It says it's 85, but on the machine it's going to be a 5-degree angle because 90 minus 5 is 85. All right. So the plan is to make this 3/8 or 375 thousandths square, both sides, and face the edges to make it 202 inches and 375 thousandths. And we're going to use the mill for that. So almost all set up actually already. So I'm going to grab some parallels here, and I'm going to use 2 this time because these are thin. I could use 1, but I'm going to use 2 this time. And if you notice, I didn't do something, which I'm going to do right now. I'm going to clean out the vise. Always cleaning out the vise. Make sure there's no chips. Clean the parallels with a rag. All right. And bring this up here. All right. I'm going to show you a little trick that I do. I hang a little bit of the part off the vise. The reason I do that is so I can take some calipers and measure how much I'm cutting. So let's get this in here. Make sure that, and they're nice and good there. Snug that up. Let's get a cutter in here. What I'm going to be using is a 1/2 inch 4-flute solid carbide end mill. The finish will be, the reason why I'm doing it is I actually care about the finish of this. I'm going to be sanding and buffing it, and the finish will be a lot better. Or I'm sorry, it'll be easier to finish. Pop that. Open this up. Oh, sorry, I'm looking at my phone to make sure we're looking good. And so sorry guys, I'm gonna, I gotta turn the mill on. That's not that bad. Let me get rid of this stuff. Need these and some oil. I'm gonna use a little bit of cutting fluid. Yeah, I think that's good. And I got good safe glasses on so I can get in there for you. All right, let's see. Oh yeah. So what's the spindle speed? Spindle speed. I'm going to use 75. So spindle speed 4 times, I'm going to use 75 as my cutting speed, divided by, whoops, 4 times 75 divided by 0.5, 600. So I need to set my spindle speed to 600, okay? And we'll do that. So that's about 600 there. Alright. What I'm going to do, I'm going to get this up close here, and I'm going to touch off. So I'm using the knee, all right, and I'm bringing the knee up. And I'm just listening and watching, and I just want to touch off. There we go. So I'm going to use X handle and back off X a little. And let's see. That looks good. And then I'm going to cut air. Spindle, my feed rate's too fast. See that? There we go. That looks pretty good. Yeah, so I adjusted my feed rate on my power feed, and I'm going to zero out my my knee. Okay. So here we go. It's gonna just a little tiny bit of cutting fluid. Oops. I forgot to make a cut. Let's try 20, and then I'm going to 20 there on the dial, and I'll zero that. So that way, yeah. So that way, when I cut, I've got my zero, right? I got a zero. So that's sounding pretty good. We want to go all the way off the part. I'm just going to Y over. And okay, let's turn that off. Got my rag here. Ooh, that's nice. Okay. Yeah, there are some cutting lines in it, but they will sand out, no problem. I can feel it with my fingernail. That won't be an issue. So this is I was showing you that little trick. So we started with a half. Okay, 498. And we cut, remember we cut about 20. So there's 78, that's about 20. We want to bring this down to 375. So what I'm going to do is and I'm zeroed out on the knee. I'm going to go 78 thousandths in passes of 25 or 20s, and when I get to 400, I'll take another measurement. That way I stay in control. So a little bit of cutting fluid. Okay, so let's do a 25 and see if we can get away with that. Might be too much, but let's see. Oh, looks good. Alright, so let's see here. Okay. And so we should be at about 403. 403. So we'll do 20 and 8, and that'll do it. All right, we'll do 20 and 8. That's too much oil, by the way. I'll just zero this out again, and we'll do 20 and 8. Make sure that I'm at 375 on the money. So now what I'm going to do, though, real quick, while I have it here, is I'm going to face this. Okay. I'm just going to bring this down here. Make sure my power feed's off. There we go. I'll just move this over by hand. There. So when you're facing like this, you want to make really light cuts. See that? All we want is in case. Okay, that's pretty good. I'm going to drop the table a little. And rag here. Yeah, the stainless chips, they're brutal sometimes. You got to be careful. All right, we'll pull this out, slide this out here, and take a look. Yeah, that looks pretty good. So that we got all these burrs everywhere, you know. There's burrs everywhere. So sorry, let me think about this for a minute. Yeah. All right. That file's too aggressive. Grab this. See how I choked up on the file a little bit? All I want to do is get rid of that burr. Yeah. And I'll just really lightly hit that corner. Really lightly hit this corner. We kind of rolled the burr over. Okay, there we go, we got it. All right. Okay, that looks pretty good. So I know my phone's out. That's not good practice, and it's not good for my phone either, but it's how I gotta see. Clean out the vise. Really good. Clean the parallels. Okay. I'm going to put the side that I cut up against the back of the vise, and then the side that I faced off to the right. Real gently here. Okay. Real gently. Just, that's not very good. Let's see what's going on. That looks pretty good. Okay. So let's check this out. What does this say on the length? Just a little under 2.5. So just a little under 2 inches and 500 thousandths. 285. Let's see. How do we want to approach this? Same thing. We'll do the same thing. We'll do the exact same thing. Okay. off, touching off, touch off, back off the part, do my 25 again, remember, okay, 25, and then 0, a little bit of oil. Guys, that's actually too much oil, but it's okay. And here we are, off to the races. Yeah, I know. Okay, so now let's measure, and we'll come up with our strategy. Let's measure here. 471, 470. Okay, so can't do 100 because then we'll go under, okay? So what we're gonna do is 70. What we'll do is 70 right now. 250, 225s and a 20. 25. To 50. 20. I'm gonna do 21. For a total of 71 thousandths, which is exactly what we will bring us right to 400. All right, so we got a little deburring to do here. Here are our parts. We got to deburr them. We got to drill a couple holes and put an angle on this and then finish them. Off camera, I ground that down. I'm not even going to tell you. I got close. I didn't want to do that on camera. Okay, so let's see. What I've got going on is I put a vise. I put a smaller vise in a bigger vise, and I'm going to use the smaller vise to hold my parts, so I can just get rid of these burrs that are on the edges of this, so we can drill holes and all that. So I got a couple files here, and I'm just going to lightly file off these edges. I'm not even pushing, okay, just in case you were wondering. I'm not I'm letting the file do all the work. I don't want to put a bevel on it. I just want to get rid of those burrs. Okay, and that's pretty good. There's still a little. I'll get that at the very end. Just okay. Let's see. I'm not pushing. I'm just basically the weight of the file, which is hardly anything. That one's being a little tricky on me, so I'll come around here. Just grab this. Got to be careful, it's sharp, you know. There we go, I saw it. I don't know if you saw that, but okay. Okay, and then that's pretty good. Just by hand, just hold that in. Just run the. Just want to get rid of those burrs. Okay, and that's it. I'm feeling them. There are some chatter marks right there with the file, but that's okay. Okay, so that's pretty much taken care of. That's done. Let's move on to these smaller ones. What I've got here is some brass shim stock, and it's really thin. So I'm just going to cut it with some scissors, and I just need 2 pieces. And what I'm going to do, it's a little finagly, but I'm going to This will help. There. Trying to hold three things at the same time is always really hard. What this shim stock's going to do is keep the vise from making an indentation in my parts. So you don't need to hold it that tight. You just need it to not move. And I'm proud, meaning that this is higher than the vise. So I'm going to take this small 3-corner file here and see what I can do. Of course, I don't want to file the vise. This vise, this file here. I just want to get rid of that. There we go. It's really close now. So I'm not going to push very hard, if at all. I'm letting the file do all the work. See, I'm hitting right there. That's okay. That's okay. Alright. It's okay. Just really lightly. There. That's good, right there. Okay. Oops. Alright. So let's take this out. And then we'll do the other one. The brass one. Same thing. Except of course the brass one's going to be a lot easier because it's brass. Don't want to mar the brass. I just barely have it in there. It'll probably, yeah, see it? It'll spin on me too. I'm just going to take this really lightly, knock it. That's what we don't want to do. I'm using my thumb actually as a guide. It's okay. Don't. It's okay. It's okay. Come around here. You can see that it's breaking off. It's okay. It's all right. And okay. Now, what I'm going to do is I got a piece of sandpaper here, some 500, and let's see, this is the side. So I'm going to hold it. I should be using something flatter than this, but these parts are so small, it's okay. And in a figure 8 pattern, I'm just going to see that? There. Okay? And I'm going to do that through all the successive grits, just like we did on the lathe in the assembly. Let's see. We might have to countersink that side. I don't think the screw will fit all the way through because there's a burr there. Well, you know. It does. And you can see it shot out some dust. Okay. Let's check the other one. That's great. That's good news. I'm still gonna lightly countersink that on the drill press. This one, no way. Yeah, no way. So there's a couple ways to deal with this. Let's see. Actually, I'm going to take this tap and see if I can break it with just by hand with the tap. I sure did. Okay, so I didn't even have to put it in the vise. I broke that burr just with hand strength on the tap. And let's see if this, there we go, check that out. That went through now nicely. I'm still going to hit it with the countersink. I'm just going to touch it on the drill press. I'm just going to, just touch it. Or maybe I'm not. You know, I haven't decided yet. That's looking pretty good. And that looks good too. Okay, so we got a couple holes to drill. We just need to go through the center of each with a number 12 drill bit. So that's not too difficult. So we'll do the square one first. I got a couple tricks to show you. So I'll go through this side here. What we don't, so if I put this in with the parallels, I am going to drill into the parallels. This is a number 12 drill bit, by the way. So what I'm going to do, and also I can't find the edges, so I'm going to do a little trick here, and I'm going to offset these parallels, I think. Actually, I'm going to go this way so you can see better. I'm going to offset these, I think. That was my plan. Okay, I know. Some machinists out there are going to be like, that doesn't work. Well, you know what? Sometimes it does. All right. Look in here, make sure I got a gap about halfway. Just need a little bit, just need to support that. I'm gonna go ahead and pull that out just a little bit more. So I've got a gap in the middle between my parallels. Yeah, see, yeah, that's why the machinists, they're like, hey, that doesn't work. Yeah, I know. But buddy, okay. Let's see if we can get this to grab it, and I'm going to check for wiggle. Yeah, okay. So, all right, plan B. That didn't work. I will put the parallels off to the side a bit. And I'll just make sure that I'm just on one side there. I think that, yeah, that's much better. Okay. And it's not the side that I want to drill into. I want to drill into this side. Yeah. Okay. This will work. I hit it too hard, and I need to be as close. There. I hit it too hard. There's no need to hit it that hard. That might move, but I'm checking mostly for wiggle, like for wiggle. See that wiggle? We don't want the wiggle. That's better. That one's good. Let's see. We can get this to go. There we go. We're in good shape now. Yeah, that looks good. We'll be able to drill into that, I think, no problem. So what we need to do is I'm going to take now you guys, there's something called an edge finder, but we're not going to use that. I'm going to show you how to find the edges with a center. And we need to drill a hole right in the middle with this number 12 drill bit, okay? So check this out. Oops. What I'm going to do is I'm going to turn on the 1980s digital readout. Can you see that? Yeah, you can see that. All right. And I'm going to use a piece of paper. I'm not going to use an edge finder because we don't always have an edge finder. And so what I'm going to do is I'm going to use this piece of paper as a feeler gauge, okay? And I'm going to move the center drill and just be able to slide this paper through, okay? The paper is roughly 3/1000 of an inch thick, okay? And the center drill is a 1/4 inch in diameter. So if I take half, and I'll explain this again, if I take half of the diameter of the center drill, which would be an 1/8, or 0.125, 125 thousandths, and the piece of paper, that would be 128 thousandths, I can line up this tip right along the edge. So I'll show you and I'll explain it again. So really gently here, I'm moving X over, and I'm gonna, there, and it just, see it, it's dragging through like a feeler gauge, okay? And so what I'm gonna do is go up here to my DRO, and get the tool, of course, off the part. And I'm going to zero out X, okay? And I'm going to move X 128 thousandths. I want you to be able to see that. So, yeah. I'm going to move X 128 thousandths over, because that's half the diameter of the center drill and 3/1000 of the piece of paper, okay? So if I move it over 128 thousandths, there, it says 128 thousandths, and then I zero it out, the center of my center drill is right along the edge, okay? So that's good, and we got that zero now. Now let's find the zero on the Y side. So just move this over here, this here. Make sure that we're not using the flutes of the center drill. We're using the shank. This around. All right, sorry, I lost battery went dead. Okay, so we're gonna go do this again on Y. Real gently bring the Y up, and that dragging that piece of paper through, okay? Get the tool out of the way. We're gonna zero Y, and then move it over 128 thousandths. All right, zero Y. Okay, now what I've essentially done is I've found this corner, okay? And so I can get my calculator out, and at this point it's pretty easy. So we know that this is 3/8 or 0.375. So half of that's 0.1875, but 0.375 divided by 2, oops, 0.375 divided by 2 is 1875. So I can move Y to 1875 on the digital readout. Okay, now that's in the right center, right in the middle, and I can take 2.375 Divide that by 2. 1.1875. We can move this over to 1.1875. There we go. You can see that. Now I'm directly in the middle. All right. So I can go ahead and drop in my center drill. Okay. I'm at to lower the table a little, and now I can put in the number 12 drill bit, and I'm going to drill all the way through. And I want to peck at it. That helps remove the chips. Okay, there we go. There's that hole. That's done. All right, take this out. Looks good. And now we're going to do the round one. Round ones are always a bit trickier. There. Okay. Yeah, that's good. That's good. And we're going to do pretty much the same thing here. Okay, I'm going to bring this over. All right. And do it again. So I'm just gonna get this up close and drag the paper through right there, okay? And then I'll lift the tool up off the part, zero out my X, and then I'm gonna move it over 128 thousandths, because that's half of the diameter of the center drill plus 3 thousandths for the piece of paper. Whoops, too far. There we go, 128. Zero that out. Okay, that's the end of my stainless rod here, and then I'll do the same thing on Y. Except this time, I'm going to bring it up closer to the end of the vise, because I don't want there to be any kind of deflection, which there likely would be because that's hanging out so far. Right about there, that'll work. Bring this in close, get my piece of paper in there. Yeah. That's okay. Close enough. I mean, we're going to be, so it's a little tight. So what I'll do is I'll say, okay, 126 thousandths. Okay, zero that out, and then, all right, so 5/16. Okay, so that's 3.125, but or 0.3125. But watch, 5 divided by 16, 3125 divided by 2 is 1562, 1563. So I'll move this, whoops, 1, 5, 6, 5. That's good. I mean, we're splitting hairs. I mean, we're not even. I'm fine with 1, 5. 157. I'm fine. Well, okay, there we go. 1565. All right. Doesn't matter. And then I'll make this say 1.375, 1.1875. There we go. And then if you look, I'll bring this down. We are right in the middle of everything. Okay? And so this is actually really important right now. If I tried to use the drill bit to drill something round, the drill bit it has a tendency to wander off. It's going to bend on you. So it's going to go off the side. It's going to hit this and it's going to come off the side. It could break. The center drill doesn't bend. And that's what makes them so cool, okay? So I'm going to adjust my quill handle here. There we go. And all right, turn this on and real slow hit this. I hope you can see that. All right, let me get a little oil in there. There we go. Now it's good. All right. So I'm gonna take out the center drill now and put in the drill bit. Now I've got basically a straight hole for that drill bit to go into. Okay. All right. So I'm going to take this out. It's a little warm. My parts. And before my batteries die, I'm going to come over. How to make small parts. Notice how gentle I am being. And how dirty I got today. All right, I just knocked that off. Okay. Okay, so let's take this over. I'm going to run out of batteries. To this mill. Let's drop this in here. And I don't have enough height. Shoot. So I need to get a parallel that's just like 1/8 of an inch higher. Totally breaking the rules, but that's okay. There we go. There we go. All right, let's see if that does the that'll do the trick. All right. And I want, yeah, we're good. I'm going to to put this here. I got the end mill in already. And I'm going to put this, I really should have something over here, but I think we'll be all right. All right. Yeah. Okay, that looks good. Okay, check this out real fast. I'm going to move the head. Break this free. Just needs to be a little bit. All right, that's good. Go around this side. And this mill's missing a bolt. All right. Loosen those up. Got this wrench, and I want to move the. So there's a worm gear in here. Nope, wrong direction. Nope, that's the right direction. Yeah. And I'm going to make this say 5 degrees. So I got the mill at a 5 degree head angle. I know I ran out of batteries again. Anyway, and what I'm going to do is put that 5 degree angle in here, okay? And this mill is pretty much entirely manual. There's no power feed except for X. It's electric, but yeah, we won't even talk about that. Okay, and so I'm going to bring this over here, and I'm not going to take any measurements this time. All I'm going to do is start cutting, and I'm going to take very slight little cuts, and as soon as the cutter, that angle reaches this edge right here, I will stop. So this will be real quick. So let's raise the table here, and all right, turn it on. And spindle speed's the same, as you know, it's 600. Oh. I'm in neutral. Do the usual touch off here. There's my touch off. Bring this back a little bit. Raise the table, and here we go. All right, looks good. I got a nice straight line. On there. So we know that my material is in there. I'll get the camera up really close. Maybe it'll be really cool. You'll be able to see it. So I know my material is in the vise pretty good. All right, and just need this. That's all it took. That's all it took. same thing. Really light. On that corner. I'm going to do that by hand as well. And what I'm going to do though is real quick on the disc sander, I'm just going to, all right. And I really want you to pay attention to how, so I'm making sure I do the right corner, how light I do this. Try and get this camera in here. Yeah, that's good. Yeah, this way. Alright. It's gonna get warm on me. Guys, I got, you know, 40 years of doing this. It's looking pretty close. Takes care of that bit, for the beginning at least. And now we're going to go back over here to the vise. Alright. Okay. And my file here. Fix this. I want it to be pretty straight in the vise. Yeah, it is. Relatively straight. And alright. I think we got it. There it is. All right. What I'm gonna do real quick is I want to ease these edges, and I'm gonna do it by hand. And I don't want these edges to be so this is a buffer. And this is called rouge. That's even too much, but it's gonna make it, it's gonna polish it out. See that? But I have more sanding to do, so I'm gonna stop. All right. And then I think I definitely will do all this off. I'll make everything, buff everything out and all that off camera, but I'll show you what we got here. There's our, okay, and then as you know, the flat side goes down. here. I got a burr still from the angle milling. That's okay. And then this goes on here, and this goes on here. And there's our little clamp. All right. Okay.